So to kick off our second half of the theater here, I would like to introduce Michelet, again, the bioprocess application scientist with Eppendorf, North America, presenting large-scale production of human mesenchymal stem cells and BioBLU, blue, SC single-use vessels. Michelet.
Thank you, everybody, for coming. Over the past few years, stem cell-based regenerative medicine have been a very hot topic in the scientific community. Stem cell-based therapy has the potential to revolutionize human disease treatment. Although successful expansion of mesenchymal stem cells is well established in vitro, the large-scale production remains a bottleneck. Today, I'm going to share with you an application which was generated in our Enfield R&D facility by Dr. Marshar and Dr. Kendaka Siddiqui. For today's presentation, we're going to go over mesenchymal stem cells briefly, materials and method, result, conclusion, and establishing process. Mesenchymal stem cells are adult stem cells of stromal origin. They serve as connective tissue of any organs. For example, prostate, bone marrow, adipose tissue, and the ovary. These stem cells are undergoing a large number of clinical trials. Among various adult stem cells, we chose mesenchymal stem cells because it is one of the most studied and has one of the highest potential evidenced by clinical trial activity. There are over 400 clinical trials based on mesenchymal stem cell registered at the clinicaltrial.gov, as you can see here. Another advantage of why we choose mesenchymal stem cells, it's because of its potential application in the treatment of these diseases listed. Just to list a few: baldness, blindness, diabetes, Parkinson's disease, Alzheimer's, and stroke. For the materials and method, for the cell line we use was obtained from ATCC. It's an adipose-derived mesenchymal stem cells. The media was mesenchymal stem cell basal media, supplemented with component of mesenchymal stem cell growth. Microcarrier, we use, for the first experiment, we used the polystyrene microcarrier from Solar Hill. And for the second experiment, we used collagen-coated microcarrier. For cell counter, we use the nuclear counter, NC100, along with Vicell's XR from Beckman. The bioreactor controller that was used for this experiment is the New Brunswick Collagen blue vessel. We chose this controller because of its flexibility and it's the dynamic of options available. This controller comes equipped with a low TMFC, which was ideal to control the gas delivery for stem cells. It also have the option for a high TMFC as well. It comes equipped with both optical and standard pH control. It's able to basically handle all the processes from batch, fed batch, and perfusion. And it is bench type configurable. For the vessel we use, the slide here is showing our rigid single wall, rigid stir tank bioreactor. As you can see, we have vessel range from 0.3 C for cell culture up to 50 liter C for cell culture. For this experiment, we were thinking ahead. We wanted to produce one therapeutic dose of stem cells, and the best vessel that was able to accommodate that was the 5-liter BioBLU 5C. So for our experiment, we used the 5-liter blue. For result, mesenchymal stem cells are very sensitive to shear. Gentle agitation at lower RPM is preferred whenever it's possible. So we did a pH study using PBF to find the slowest possible agitation without compromise on efficient mixing As shown by the graph, homogeneity or efficient mixing was achieved under 2 minutes, as you can see here, under 2 minutes. So we were comfortable choosing the agitation speed of 25 and 35 RPM for the next experiment. The inoculum preparation was done in the New Brunswick S41i CO2 incubator. The inoculum process was actually the first in the industry to use microcarrier in a shake flask inside an incubator. We choose this incubator shaker because of its low speed capability, and also no extra heat was necessary. It doesn't generate extra heat that we need to worry about, and it also was ideal for our culture because of the low sharing capability as well. And the information was also published on the Bioprocessing Journal. If anyone interested, we can share at the end of this presentation. This slide here is showing the first experiment we done with polystyrene microcarrier beads. On the left is the cell density profile. As you can see, our cell density peak reached around 400,000. And to the right is our metabolic profile, which show glucose and lactase. As you can see, we then run out of glucose, and the cell produced lactate as expected. We did a feed on day 5, a 25% media exchange on day 5, and on day 15. Even though we increased our cell density almost 7-fold, we did not satisfy with that result, because our plan was to obtain 1.6 billion cells using our single-use BioBLU vessel. So we went back to the lab and tweaked a couple of parameters and run another 5-liter run. For this run, we use the collagen-coated microcarrier. We chose the collagen-coated microcarrier because we have some literature that suggested mesenchymal stem cells is better supported on collagen-coated microcarrier. As you can see here in this graph, that we were able to reach a cell density peak from 2.5 E times 10 to the 5th. For the metabolite on the right, we did a 50% media exchange on every 4 days. So on day 4, day 8, day 12, and day 16. We terminate the run on day 18. As you can see here, had we probably continue the media exchange, we probably could extend the cell density. However, we terminate the run on day 18. So now that we have shown that we were able to grow the cells at 2 times 10 to the 5th. So we wanted to see, okay, now we grow the mesenchymal stem cells. Do they retain their property as mesenchymal stem cells? So in order to determine that, we went in and did some immunoassay analysis. And as you can see on the graph, A and B, that they did express for the marker of CD44 and CD90. Now we were happy with that, showing that, but we wanted a second confirmation. We did the immunoassay, we were happy about it, we get the result we wanted, but we wanted to do a second confirmation to double assure us that the cells still retain mesenchymal stem cells properties. So for that, we did a PCR analysis. So the PCR analysis revealed for our positive and negative control, it was as expected. As you can see on the table, for the PCR analysis revealed that we were positive for all the stem cells marker for OCT3/4, SOC2, CD105, CD90, and CD44. So we did get our second confirmation that we were positive that we were growing the mesenchymal stem cells in the 5-liter vessel blue, and they still retain their property as stem cells. So then we're like, okay, that's great. We know we grow the stem cells, they retain their property as stem cells. Now, can they do what we want them to do at the end of the culture, which is differentiate into this different cell type that we would like them to do? So for that, we run two differentiation assays. We did the hypogenics, which is for a fat cell, and asterogenic, which is bone cells. As you can see here on figure A, they illustrated by the red droplet, they were positive because red droplet is an indicate that they have differentiated into fat cells. On figure B, as you can see on the red dots here, these are the calcium minerals, which basically indicate that it was positive, that each for both of the assays, the cell differentiate into epigenic cells and also asterogenic cells. So we were very thrilled and happy about that, to see that we have actually take these stem cells from early phase, grow them into our bioreactor, get them to differentiate, which was ideal for us. So we went back and looking at our cell counters. So at very early on of the cell counter, the NC100 was correlating with the Vi cell. However, as the cell density increases, the NC100 was unable to keep up, so they differentiate. So for that, we went back, trypsinized the cells of the microcarrier, and put that sample under the Vi cells. Then we were able to basically went back and corrected our growth profile, which basically shows that we were able to successfully produce around 0.4 million cells per mil, which gives us a total of around 1.6 billion cells overall. So in conclusion, the BioBLU 5C with a maximum working volume of 3.75 liter is capable of producing more than one therapeutic dose of 1 billion mesenchymal stem cells. We also show that adipose mesenchymal stem cell culture in the BioBLU 5C single-use vessel retain their differentiation and multipotency properties. And also, we show that general applicability of the Collagen Blue system in the BioBLU vessel for large-scale adult stem cells was possible. We also showed that we were able to produce enough stem cells for regenerative medicine under CGMP environment. And we also have data supporting that we were able to scale up to the next level, which we will be doing, which is the 50-liter C single-use vessel, and forward onto larger scale. Now here at Eppendorf, we provide a one-stop shop. We have product basically supporting anywhere from R&D with our cell consumables, the S41i incubator, which can put up to 120 shake flasks, along with T-flasks in there. We also have the DAS box system, which can be used for media optimization, clone and cell line screening, and strain characterization. in the small scale aspect. Now, for the process development, we also have the Dorceus, the Collagen Blue, which I just showed, we use for this presentation, and of course our new flexible BioFlow 320, which is able to accommodate both microbial fermentation as well as cell culture. Now, for the large-scale vessel, we also have the Collagen Blue, which is able to control and run the BioBLU 50-liter C, along with our 610 stainless steel CIP system, and our BioFlow Pro 2000. Thank you very much for coming in. I'll take some questions now if there is any. Thank you. Yes, sir. Can't make it out. I'm sorry. Can you? So the gentleman would like to know what's the cell viability after 18 days, and it was 98%. Any other questions? We also have the application note that was generated for this experiment available if you want to stop at booth 3335. Thank you very much, everyone, for coming.